Hi everyone, how's everything going? Good, great. Likewise, long story short, today we'll look into some advanced techniques of machine learning commonly named as multi-class and multi-label. To make it clear, I have put the diagram from the scikit. From the above diagram, we can clearly see how they are split into. Number 1, multi-class. This we are already aware of, and most of the sklearn classifiers support the multi-class by default. Here is a list below, just in case. Inherently multi-class, like naive Bayes tree classifier, extra tree classifier, extra trees classifier. Then you have the k-nearest neighbors, label propagation, and so on and so forth. Multi-class as 1 versus 1, SVM, NU, SVC, SVM, SVC, Gaussian process, and next is multi-class as 1 versus the rest. Ensemble methods like gradient boosting classifier, Gaussian process classifier, linear SVC, SDC classifier, stochastic gradient descent classifier, perceptron, and so on and so forth. Now, again, we have this support multi-label, extra tree classifier, extra trees classifier, decision tree, neighbors, ridge classifier, random forest classifier. Then you have support multi-class, multi-output, decision tree, extra trees, radius neighbor classifier, random forest, and the list goes on. Next, we have number 2, multi-label classification. We call it multi-label classification because we will be performing classification tasks, and for regression, we will call it as multi-output regression. Multi-label classification is further divided into multi-output classifier and the classifier chain. Multi-label, multi-output classifier. This strategy consists of fitting one classifier per target. This is a simple strategy for extending classifiers that do not natively support multi-target classification. Here is the default snippet, where you can see we are calling sklearn.multi-output import multi-output classifier, then CLF equals to multi-output classifier logistic regression, then fit the data X and Y. Next is multi-label classifier chain. Classifier chains are the way of combining a number of binary classifiers into a single multi-label model that is capable of exploiting correlations among the targets. Each model makes a prediction in the order specified by the chain using all the available features provided to the model, plus the predictions of the model that are earlier in the chain. In simple words, for example, classification of the properties type of fruit and color for a set of images of fruit. The property type of fruit has the possible classes apple, pear, and orange. This property color has the possible classes green, red, yellow, and orange. Each sample in an image of a fruit, a label is output for both properties, and each label is one of the possible classes of the corresponding property. Here we are, we have the snippet. So what we can see out here is from sklearn.multi-output from classifier chain, from sklearn.multi-output import classifier chain, and then you have the chain equals to classifier chain Bayes underscore other. That is the Bayes model. And here we have our logistic regression. Then auto random, and the random still equals to 0. Then we fit the data with X string and the Y string and predict the test dataset. Now we can perform the same for a regression problem, and we call it as multi-output regression. Similarly, further divided into multi-output regressor and the regressor chain.